All right. So yeah, welcome to week 2, right? So it is Tuesday, so it's a little bit shorter of a week. So just I already put this on the announcement on the homeroom. People saw that announcement this morning, and then it kind of reminded people a little bit on Slack itself about the stuff like the schedule. Today we're going to kind of focus on like the second half of um, what's it, topic 4, and then go right into topic 5. Tomorrow we'll go over topic 6, which is like data visualization, all that good stuff. And then on Friday, remember Thursday we have that, kind of digestion day. On Friday, we will talk about section 7 and 8, which is going to be SQL databases and NoSQL. So just know that is technically 2 sections, but if you look at section 8, I don't know if anyone took a peek at it, it's like literally like 4 lessons in there. And we're not going to like really dwell a lot onto NoSQL because there's literally NoSQL means not only SQL, which means basically SQL but not SQL. Like so, it's pretty much like the other half of the coin, which is pretty big. So we're just going to kind of ignore, like we're not going to go into too deep parts, but just kind of know is that we'll go over those 2 sections, stuff like that. Yeah. So we'll get started then. I'm going to start sharing my screen. And remember that we're going to do more of an hour and a half study group. So that's going to be the more typical now. And I think you guys saw from last time that that was kind of closer to the truth from last study groups. And that's just because there's just so much to talk about. All right. So let me go start sharing my screen and we'll get started. So share screen. Cool. And then do you guys see my repo right here, Flatiron Curriculum Resources? Okay, see, no, it's good. Awesome. So let me just make sure, close some windows here. It's a little bit easier for me to navigate. And this way I can see you all too. And I'm gonna move the chat next here so I can see you guys. All right, cool. So like I said, we're gonna go over section topic 5. And so I just wanted to show you guys where to find a lot of this stuff. So I think I already pointed you guys in this direction already of this repo. I had a couple questions about like what exactly is this? This is just really like my like notes essentially that I use for like leading study groups and stuff. So note this is kind of like, it's not the main curriculum. It's just kind of like the thing that I use. And honestly, I use it because it's convenient for me. And it just ends up being a little bit easier, I think, in the long run for students. Right now, you can see that in the main branch is that this curriculum V2.1, we're actually going to be a little bit deviating from this. So I'm going to make a new section here in the README. But when that section comes up, you'll see like the module, like, or in this case, we'll call it for topics now, or say the phase and then the topic. And then I'll kind of list the notebooks that we talk about. And then I try to put the recordings there too. But everyone knows how to find the recordings now in the playlist. You guys know what I'm talking about? Good. Okay, cool. I saw a few people have already seen it, so that's great. But I'll put them in here too. And so that will be in this new section in here. If you really want to have everything up to date for our specific cohort, if you go to this branch area right here on GitHub, you see this is the main branch. But if I actually go to FT011121, which is the name of our cohort, right? You can actually see this branch and see a little bit the slightly more updated. In this case, like this one was updated 8 days ago. And so eventually the main branch will reflect everything that's in here. But if you like really want to like up to the date, this is a good one to kind of check out. Okay. Cool. Any questions about this? I just wanted to point this out since we're on week 2 now. And I've been using a lot of these notebooks. Okay. So today we'll go over data science basics. And so most of the stuff we're going to talk about today is in Pandas. And then tomorrow we'll actually be living in a lot of this directory visualization. So just kind of know data science basics, Pandas, and we're going to go through most of this stuff. We actually talked about this last time in the last study group. So we'll review that. Sound good? Awesome. Cool. I don't know if you guys can hear a little bit of extra noise. It's extremely windy on the Bay Area this today. It was high winds. So if you hear a little extra crash, no, I'm okay. All right, so I just wanted to review real quick what we had from last time. We talked about Pandas and kind of introduced that. We showed a whole bunch of different stuff, a little bit about series and data frames. Those are the 2 main things that you should really kind of like remember about Pandas. And then we talked about kind of like manipulating, like adding data into the data frames, how it's basically built on top of different series. So each column is essentially a series. And data frame is kind of more like an Excel spreadsheet, if you kind of are familiar with that kind of concept. We talked about a little bit of missing values, what that looks like, and a bunch of other methods that we can do to load in data and also export that data. And then we also talked a little bit about some methods for actually changing data and stuff like this. We didn't go through all the details of exactly how to use it, but we showed that. We showed a little case study here where we basically put in some data into our data frame. And then we got some methods to actually look at the data itself. So info, describe, we'll see that again today. And then we talked about attributes a little bit. So just like there's some attributes of the data frame itself. Okay. And then the last thing that was kind of the most advanced stuff that we did was the Boolean mask. So no, basically it's like essentially it's a filter, right? We're essentially saying, oh, only grab these elements based on these criteria. And so we talked a little bit like what that looks like. Okay, cool. Sound all good? Sound pretty familiar? Hope you guys got through that. Okay, and that's mostly from topic 4. So what we're going to go to next is actually into manipulating data. So once we have data in our data frame, we usually want to do stuff with it, right? We want to kind of play around with it and see how it works. So what we're going to do here is we're going to just go import pandas as PD. So remember we do this always. And in this case, I'm using sklearn. So this should already be installed on your guys' environment. And I'm just doing that data sets again. In this case, last time we did like load wine. In this case, I'm loading data diabetes. And so you can actually look at, I actually put the documentation up right here. So I like to show you guys where this is all coming from. And you can see a little bit, it gives you some documentation about this specific data set and such. But I'll let you guys look at that in your own time. So we're going to actually just load it directly into here. So we say data is equal to load diabetes. And then now memorize this data.data. Note that these data and this feature names is specific to from the load diabetes formula. It's not built into Pandas or whatever. It's just referencing from this guy. Okay. So we load that in, and you can see it took some time, loaded it in, df.head. So we can see the first few records, and you can see here we have some columns: age, sex, BMI, BP, S1, S2, S3, S4, S5, S6. So like these ones, for example, like I think age and sex is pretty understandable, like what that's supposed to represent in BMI. But you might not be familiar with S1, S2, like that might be something specific. This is where you would look at the documentation, right? Which is built into that function, but you'd probably like look it out and say, hey, like what are these things, like what do these things mean? So just kind of know a little bit context. But in this case, we're just going to flop forehead. So kind of quickly looking at this, what are something we noticed when we do this df.head, like about this data set? And maybe a little context of like saying diabetes and like some of the attributes. What stands out to anyone?
Like the age and the sex, the way they're written are just floats, and we need to have them as different types, I'm assuming.
Yeah, so this is probably like not immediately noticeable, right? And in this case, you know, it's not super easy. Like, what's going on exactly with age and sex and stuff like that? Like age, like it definitely like no one like I don't know about like what is this unit exactly? You have a negative age right here, so this might be kind of confusing. What's going on? Sex, it looks a little more binary. You can see there's a value here that's exactly the same as this value, right? So possibly it's binary, possibly it's not just binary. Maybe there's another value. Sex, for example, could be unknown, right? So you'd have to look at the documentation to make sure. But yeah, good point is that these are all float values where they probably wouldn't make sense as float values in most situations. Does anyone by chance, like just out of curiosity, does anyone know actually why there are these values, like why they're floats?
Is it because they've been normalized based on the entire data set kind of thing?
That's right. It's because it's been normalized. That's exactly what's going on here. Is that basically they're centering the average value. I think in this actually, yeah, I think it's the average. It might be median even, but I think it's the median actually. They might be centering it at the median or the mean. I can't remember which. And basically using standard deviation, say, okay, like how far from the median are you from this part right here? Is likely what's going on here, and that's a really common situation. Certain machine learning algorithms actually rely on having something that's centered around 0, where we have like the mean or the median centered around 0 and the data around here. So that kind of makes sense. In that case, you can kind of see there's probably at least more of this sex than the other one because this value is slightly more. So it's kind of leading it towards that direction higher, if that makes sense. And that's why we have these negative values, because it's a certain value below the, I'm going to just say the median because I'm not sure exactly which one it is. Good. So yeah, those are good spots. And you can actually see if you look closely, like all the values are like that. And that makes sense. It seems like all of these are been normalized. Okay, so let's kind of check this out. So like I have some suspicions, first of all. We're going to talk about how to do this, but I'm going to have some suspicions about like sex. Like, is that going to be binary? Is that going to be more than one class? I kind of know about that. And age is going to be something, there's going to be some kind of range. But there might be useful know like what is this age range? And then the sex, for example, like how many different classifications do we have? So kind of quick review, because we're going to use this a couple times. Anonymous functions. So remember, you can define a function like this. In this case, this is called double. Excuse me. We just take a parameter in, right? And we just say, okay, let you just take that number, whatever that is, and just multiply it by 2. We can do the same thing with the lambda function, right? So we remember this before. Okay. So we can also, like I said, like this before is like, oh, just as a function, we can actually like set the function equal, like double me equals lambda x. So this basically creates a function called double me. And you can see here, for example, I can pass it the letter a, which should do, the letter a times 2, which gives us AA. Okay. Remember that we can also have 2 parameters too. So in this case, we have x, y, and I can actually use those x, y's together. So I can have a 2-parameter function. You can technically do more than that, but usually lambda functions, just because they tend to be very small, usually at most you would have like 3 parameters, and even then that's pretty rare. Okay. Sound pretty good? Okay, cool. So just kind of quick review, because I want to show this. So kind of going a little bit, it's like, all right, let's kind of explore a little bit of what's going on with this guy. So if I want to get just the age, I can do df, and then you can see this brace right here, kind of like, remember how we would call it in a dictionary? It's kind of similar to that kind of feel to it. And I'm going to say, oh, grab me the age column. And you can see it, I have df age, and I can say, show me the first few values. And you can see here, here's the first few values for age. Okay. So note that if I didn't have head here, it would just show me all of the values, or it would try to show me a lot of the values. In this case, display actually kind of cuts it off, so you don't see all of them. But you can see a little bit what's going on here. Okay. So I can also see what the type is. So I can see what is this type, and you can guess like, oh, this is a series, right? So we can just double check that that's actually working. This would normally not be this, but kind of remember that this is actually a series. Okay, just a column. So let's do some stuff with it. So let's say for age, like, you know what, this, like these values, like if I do this, these values are a little bit harder for me to read and stuff like this. And you can see they're pretty small. So let's just say, for example, I just want to multiply it by 1,000. So I'm going to just move that decimal place, what's it, 3 times, right? So if I do this now, you can actually see is that I put my result here equals the df.age.map lambda x. And then this function right here, it's just multiplied by 1,000. So the new thing is probably this .map here. And this map basically just says map every, take every value that's in this, in this case, this series, and map it from this function. So mapping it basically saying, take every input value in here and then say, okay, put that as a parameter into this function. In this case, this function was multiplied by 1,000, and then return the result. So you can see here is that it makes every value just multiply by 1,000. Does that make sense to people? Okay, cool. See lots of heads. You can see here is that I can do the same thing with the normal function I called double right earlier. So remember, double just multiply it by 2. I can just pass in a function too. And note that the function is just the function name, not with parentheses. That's why lambda is really useful here. And you can see I can do something similar. In this case, I do .map. Oops, I should make sure. Oh, so I did a couple things in here. So let me kind of break this down. So one thing to note is that my result, remember how I multiplied by 10? If I check out df.head now, note that age has not changed. And that's because, remember, this is, Pandas likes to do things what we call out of place. So it does things, it doesn't directly affect the data of df. It's basically taking a copy and creating a new thing. And that's why my result is something different now. So just kind of know that there's a little bit there. You could technically do something called in place, which basically will replace the data in here, and you would see this change here. Or there's a couple other ways, what I'm going to show you in a second, overwriting this data. But just know that by default, it doesn't do that. So what this does right here, I'm just doing df.age.map.double, which is applying this specific function, right? So I'm applying this double function to age and making a new series. And you'll notice that this right here, df double age, at least from the original data frame, double age did not exist, right? That's not a real column that we had, right? So just note that if I had like a column, so just kind of quick like pop quiz a little bit, like what happens if I do something like, new column? So this column doesn't exist, right, in the original data frame. What would happen if I run this? I see Sam unmute. I don't know if he said anything.
I was going to say something, but I don't think I'm right. But what I was going to say was that it creates an empty column.
That would be one option, right? Maybe it just creates a new empty column, right? So turns out though, and I think I heard someone say it.
I think it will throw an error.
Yeah, throw an error. And it turns out, yes, it does a key error, just kind of like we would expect with a dictionary. It says, hey, that column doesn't exist, right? So it doesn't really help us. But this right here basically says, hey, df double h. And before it basically does this, it says, hey, don't just throw an error. We're actually going to set that equal to some values. And in this case, you can actually see when I do df.head now, you can see that it actually adds that double age now as a new column. And you can look at that closely. 0.076, that's double of 0.038. So you can see that that actually worked. And this is usually the preferred way if you make new new features, you would just add them in like this. Basically, oh, like this new column that doesn't exist, set that equal to this. Kind of like a variable name. That makes sense to people? Cool. Note that I could have done age like this. So if I do this right here, note that this will actually overwrite. So I'll actually show that right now. And when I run this, it's actually going to overwrite age. And you can see here now, if I run this guy, instead of 0.038, you'll see that one changed to 0.0 or 0.076, right? And you can see that's changed right there. So this is usually like, you'll see people do this kind of like notation frequently. This is kind of a bad habit unless you know, like, unless you're very certain this has to be done. Usually the more common thing is to add it as a new parameter or even copy the data frame and make a new data frame, like, df, age doubled or something like that, or df processed. So just kind of knows that usually good practice is to actually create a new column or even create a new data frame versus changing the original data frame. Because now if I want to go back to the original age and do something with it, it's not an easy thing to do. I have to like undo that, thing. I have to like do an inverse or just essentially load it back again. So in this case, I would literally just like load it again. You can see here, now I have my original data. Okay. Make sense? Cool. All right. In this case, I'm actually gonna, in case past Victor did something, I want to make sure I don't mess myself up. So there we go. I'm gonna keep that double H on there. All right. So some cool stuff we can do. All right. So let's see. I want to see. Okay. So before I go into this one, I did want to show you a little quickly. We kind of like this sex part is kind of like I want to know, like, is there more than one group? Like, what's going on here? What we can do df. Well, let me ask you guys, what can we do to kind of figure out like, hey, like how many groups are there? What could we do?
We could do .info or unique.
df. I'm sorry, say that one more time.
Either .info or I would do unique. .unique.
Yeah, so we could do df.info. So that's one option, right? So I think that's actually one I would probably do immediately just because I usually like to check that out. You can see a little bit of the values. In this case, it doesn't tell us exactly what's going on, but we can see there's nothing null. And another option that Samad also said is unique. So let's try unique real quick. So note that this is not actually going to operate on a data frame. You would actually have to operate this on a series, right? So sex is what we were caring about. And you can see here, there's only two values. So that kind of makes sense, at least for how most of our data set is probably, male, female, for example. But it's possible we have another third type, right? Could be something like, like not known, or it could be, depending how things are classified, right? There could be like multiple classifications and like what that means and stuff like that. And we'd have to go back to documentation. Note that this is how we would do this for a series, right? We could also do df. Well, never mind. I'll just keep that for now. There's other ways we could also get unique values and stuff like this. Okay, cool. All right. So cool. If we move on then, new data frame. All right. So let's see a new data frame here. You can see I'm using sklearn a lot, and you can see there's a new documentation here. I'm going to do fetch 20 news groups. One thing to note about this is that basically this guy is going to be a lot of natural language. So think of like sentences and stuff like this. So in this case, you can see I'm already doing some extra stuff. So fetch 20, I'm actually getting a subset called test. That way I don't get the huge amount of data that's in here. And you can see here, I'm actually saying data. I'm actually just saying the columns. I'm defining the columns myself. I'm just going to have a column called text. If you look at this, you can see it takes a while because it's loading up that data. You will see a data frame now that will have one column, which is text. And that's going to have all the values in like the text in there. And you can see here, this is the text that's going on. And you can see it's cut off right here with the dot, dot, dot. So it's just kind of going on. And we, of course, have the index. So a little bit different from what we had before. Maybe kind of similar to like if you guys did like Macbeth, right? Kind of going through here. So what I might want to do is like, like, hey, I want to know like how like you can see that it's actually like different groups. So for example, if I grab the very first one here. So if I do df.iloc, say 0, you can see this is the very first value in here. Oops, and df news. Sorry, that was from the original data frame that we're looking at. There you go. You can see this is the first value here. So you can see this is the full text, and you can see, oh, it's got a little like message in here. And so maybe, for example, I want to measure for my problem, like I want to measure all the good words, you know, like all these nice positive words. And so in this case, I might want to know good words like awesome, love, good, and great. Like, you know, I want to see how positive people are. So I'm going to define this list right here. And this guy right here. So for the record, I split this up so it's a little bit easier for us to like read it together for first time. But you normally wouldn't write the code like this. So just kind of know that I come to this just for us right now. I'm going to do something called sentiment. So I want to add basically on the text here, on the data frame, like what is the sentiment of this, you know, this string, right? So in this case, what I'm going to do, I'm going to take df news text. So remember, that's just the column of stuff. And I'm going to map, right? And so remember, map is basically apply a function across every value. In case this value is going to be a string, right? So basically, I'm going to say, all right, for this first, you know, whatever the string is, do a function on this, right? And then return me a value. So in this case, I'm actually going to create a lambda function. And so what I'm going to basically have is it's going to take in the string, right? And then whatever the criteria is next, if it's that criteria, say it's good, you know, like I'm going to basically have an output of good. And then you can see here, my criteria here is this if statement. And then otherwise, if it's not this if statement, we'll talk about this in a second, it's bad. So it's like, oh, is this good sentiment or a bad sentiment? Okay, makes sense to people so far? Okay, so this is just the criteria itself, right? But this could have been any criteria. So that's what's going to happen here. Now let's say, okay, what is the actual criteria? So this is like little special stuff. So this any basically is a function that says, if any of these things in this like list of stuff is true, then it's true too. Does that make sense? So that's what that any is looking for. In this case, and then say, okay, what's in that list? Well, okay, what I'm doing here is a list comprehension. So kind of quick thumbs up. Who have you seen list comprehensions? Whether it's from the curriculum or something I've done. I don't think I've done it so far, right? Okay, so list comprehensions can be a little bit of a mind blow, but basically just know it's going to be our for loop like written in one line. Again, I kind of split it up just so for us to read it. So you can see what I'm going to do is that I'm going to grab a word for every word, like for every word in good words, right? Good words is what I define. Awesome, love, good, great. And I can say word in x.lower, right? So what's going on here is basically saying, is this word from good words? So like is the word awesome in x.lower? So note that I did in right here because I want to say, hey, is the word awesome, you know, and note I've made everything lowercase with x.lower. Is the word awesome anywhere in this string? That's what I'm asking. I just want to know, is that true, right? And then I do that repeated over and over for each good word I defined. Awesome, love, good, great. Does that make sense to people? Okay, so hopefully that makes more sense as I kind of break it break it down in this way, is that we're essentially what we're saying, hey, I want to know, like, are any of these words present in here? And if any of those words are present in here, I'm going to mark that as, oh, that's a good sentiment. Okay. And so this is kind of like how you can use, for example, that lambda and that map, and you can see this list comprehension. Like this is like, I kind of pulled this, you know, put this together, but this is kind of a beauty of like all this different stuff that you might have like learned right now. We got list comprehensions, we got if else, a ternary operator, we got map in here, we got, you know, what's this right here, the series, and then we're adding a new thing to a data frame, whole bunch of good stuff. So you can see here, that worked pretty quickly. Now I do df.news.head, you can see here, I can get bad, 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 good. So just know that like, oh, I just basically said, hey, if this word exists inside there, mark it as good. Make sense? Cool. Note that if I just want to say, oh, I want to add a new word in here. Let's say, for example, I'm going to pick something that's on here. Let's call models. So we'll say models is a good word for whatever reason. I can say, oh, I'm going to define this, run this guy, and now I can see it. This should at least go good. Do that. There we go. Makes sense. So this can be a really useful way, like, you know, you'll see things like this where you're like, want to basically create new features. And this is actually called feature engineering, where we create something that's, in this case, like natural language processing. So natural language meaning like the things that we talk about. We'll talk about this way further out, but it's very informational dense, and we can pull out this information by doing extra processing. All right, cool. Any questions at all? especially, I know this is a beast of a thing right here, but if you guys have any questions, feel free to ask now.
Could you take out the comments? What would it look like just normally written?
Oh yeah, that's a good question. So let's say like I didn't want to be nice and write it like, for however people want it. So I would get rid of, let's say, so right now I'm doing, so you notice I'm actually editing multiple lines. I'm actually, if I do control click, I can actually edit multiple lines, and then I'm just gonna delete all this stuff. Well, I can't do this on my computer because I just realized I don't have that mapping. But you can edit multiple lines. So I'm just gonna get rid of this guy, get rid of this guy, get rid of this, get rid of this comment. Okay, and then I'm just going to squeeze everything together. So note that first of all, I have this dot map here. So if a more complicated function, I probably wouldn't use a lambda function, but this is like relatively short, so I can like kind of put in one line.
If it was more complicated, would you be doing like a nested for loop? Is that kind of the concept here?
Yeah, like if it was something more complicated, I probably would define this function outside of this map.
Oh, okay.
So,
okay.
Yeah. So like in that case, like what if, for example, I wanted it to return, good if they use let's say like return good if they use the word good or great, but then like, amazing if they use the word awesome or love, or something like that. Or then I also wanted to have, bad. Like those are a lot of conditions. I might just then write a function that's separate from this thing. But in this case, even though it's a little bit long, you can see a little bit extra, is that it's relatively readable, like as long as you know the different parts. I don't know if like that scared anyone. It's like, oh, I shouldn't be able to read this. But basically I can read, a map means apply whatever that comes out next to every part in the data frame. And then basically says, okay, it's going to be good. It's good if any word in x.lower for word and good word. So basically, if this good word, and I could even put like good word, like that might have been a little more clear if I put like good word. Okay, so like, it's like if there's any good word in the text, make that good. Else, make it bad. So, obviously, you have to get used to a little bit of reading this part, but it's relatively like breakdown. Like you can break it down pretty quickly. And that's kind of the idea of having these like one-liners in here.
If you were to write this as a normal function, I think you don't probably use the if any, right? You just use if.
You might still use any. You could probably shortcut this in a little bit because
No, I
you
mean
could do
as a separate function if you have to write as a separate function.
if it is a separate function, it depends how you want to operate this. But like you could write the function like exactly how I wrote it. Just put like def is good. I could just like literally have that, and that would be my function, if that makes sense. But you might not think in this way. You might instead say, okay, let me just go ahead, for good word in what's it, good words. So now that I'm using a global variable,
Right.
it's okay.
Yeah, this is what I was thinking.
You could do something like for good word, if let's see here, good word in x.lower, I could just say return good. And then what that's going to do is going to go through every good word, right, that I have in that list and see, is that, oops, I should probably indent this one. If that's true, right, if there is a good word in anywhere in that list, it's just going to say, oh, is awesome in that like string? No. Okay, let me check love. Is love in that string? No. Keep going, keep going, keep going. And if it does find it, it's just going to return good. Otherwise, I can say return, what's it called? Return bad. So if it goes to this whole list and never finds good, it'll never return and then drop down to here, which means it defaults to bad. So this might be one way you might write this function if you did it from not a lambda function.
So the x here is
this string. So I could say something like,
is the cell one? Yeah, the
x is an argument, right?
That's right. You're talking about this guy right here.
Yeah.
Yeah. And I'm sorry, Simon, you were saying this guy right here, what does this represent? Like in our overall thing?
Yeah, the cell value, right? So whatever
Yeah,
text,
it's going to
the
be
whole text.
like, yeah, for example, the first one will be, this will be all of, string input or X, they formerly called it. Yeah. So you can see like this function can get pretty like big and stuff like this. And like, this is fine. Like, this works good. And like, in fact, this might actually be slightly more efficient depending on how lazy execution works, bunch of big words and stuff like this. But, this might be pretty typical, for example, if you're doing a lot of stuff in in natural language processing, where you have like these very quick one-liners and stuff like that. Because imagine like if you're doing this like for many different sentiments, like for example, you have a list of like good words, bad words, medium words, whatever, right? And you have like separate lines, you'd have to define every function every single time, where you might just have literally change like one part in here. You might just write a quick one-liner. So it just depends on the situation. And just to point out that it does work, right, is that I'll just go ahead and just replace this with is good. And this should work. Oh, I got to run it first. Nope. What did I do wrong here? Oh.
And colon.
You guys didn't catch my missing colon. There's a test. No. All right, so you can see here is that it should give me the same output. There you go. Okay, cool. Good questions. Anything else?
Just real quick, this is a silly question, but you pulled the subset test. I mean, you just knew to do that. Is that right? When you
Subset. Oh, this one. Oh, yeah, this very like up here.
Yeah, when you pulled your data, you just knew that you needed.
Yeah, I'd have to look up the specifics of this function.
Okay. I just want to make sure I had anything we needed to.
Yeah. yeah. I wouldn't expect you necessarily to know like immediately. Like this is just specific to how this data is pulled up from this documentation. Cool. All right. Cool. All right. Cool. If we move on then. Awesome. All right. So just one other example. You can see a little bit what I've done here. Like this is probably closer to like a little more readable, where you wouldn't want to necessarily make a huge thing. So for example, I realize there's only two classes. We saw already is that, if this is like zero, like there's either 0.05 or negative 0.08, like we can look up documentation of which one corresponds to what, but I'm just going to call it female and male just because. And so I can make this, I can just overwrite the sex column right here. And I can map this function right here. It says, oh, is it like based on this value? It's female. If it is this value, if it's less than 0, if it's greater than 0, just make it male. So you can see here now. From that, now I can have the sex here: male, female, male, female. Okay, so this might be another reason why you might do this. Like, if you imagine you could technically write a function that does this, right? Like, but like it kind of be an extra part, and then like you have to debug that part where it's like, oh, like, oops, I made a mistake. It actually should be greater than. No, in this case, well, I can't do it again because remember I overwrote sex, which is why you don't want to overwrite your values. So that's why it's giving me an error right here, is because sex is actually now a string, not a value. Okay, so why you shouldn't do this. Make sense? Cool. All right. Sound pretty good?
Mm-hmm.
All right, awesome. So let's move on then to the next part. So this is kind of like show you a little bit. Let's do some exploring data. So this is kind of closer to like what you might do, kind of an initial step of like in the project or other data sets. Like it's like, okay, let me just go kind of dig right into the data. So I'm going to start loading in some data. So I have a CSV here. You can see it's data titanic.csv. And I'm just going to go ahead and import my NumPy and Pandas. I'm actually going to go ahead and put this little guy right here. I should actually import. I don't know why I didn't do this. Well, I probably don't need to, but I'm going to import anyway. So I can import matplotlib. .pyplot. SPLT. So this is very common right here. This is kind of for matplotlib. We'll see more of that tomorrow. But this magic right here basically allows me to plot the graphs right here. And the reason why I have this without the import here is probably because I use it for Pandas actually uses matplotlib. So that's actually why I don't have to explicitly state it here, but it's probably good practice if I put that in there. Otherwise it's confusing for me later on. So df equals pd.readCSV. So remember this guy right here. Oops, pyplot. There we go. See errors. So there we go. We import this, and now we have our df.head. So we read this whole thing. Let's see what's in it, right? So it turns out to be a CSV, and you can see here there's unnamed 0, passenger, survived, p-class, all that good stuff, all the way to embarked. And you can see a very varied data frame. It's got some integer values, it's got some float values, it's got some strings, it's got strings with commas in it, all this good stuff. So this is the kind of like varied data you might have for a CSV. So, okay, let's do some df.info. So remember df.info should give us the overall thing. And you can say, ooh, this is interesting, right? So you can see there's 891 entries, 0 to 890, those are the index. You can see there's 13 columns. And then you can see the different types, for example, in 64, object, remember, is going to be string. In certain versions of Pandas, this will actually be string. Just know that in general for this version of Pandas that we're using in the course, it'll be object. And then you can see float 64, so we have some interesting stuff. And then you also notice here, 891 null, so that means all the entries are non-null, not empty. But you can see here, age here, ooh, there's 714 non-null. So it means we're missing about, 180 different values here. And you can see cabins even more significant. There's only 200 values out of the 890 in here. So you can see a little bit like quickly, and you can see even embarked, there's a couple values missing. So that might be something to investigate as well. So this kind of gives you a quick view of like the data itself. Okay, makes sense how I kind of saw all this, right? Cool. So if I do df.describe now, you can see I can also get all the numerical value or columns, and you can see a little bit of like how many are in there. Then we can even see the average, for example, the average of at least the ones that were in there is 29. We can see the standard deviation. So 14 years, which is a pretty big, standard deviation, especially considering the average is 30 years old. There's a high difference. And you can see some minimum values. So you can see 0.42, which might be something interesting. Like, I don't really know how many people keep their age at like 0.42. Like, I wouldn't think of my babies are under 1 year old and I wouldn't use that value, right? So that's kind of an interesting one. And you can see the maximum value 80, which seems reasonable, right? It doesn't seem something that's like outrageous. It's not like 1,000 years old or something like that. So we know there's probably no issues there. And you can kind of look at a little bit of what's going on. Okay, makes sense? Cool. All right, so we've got some stuff. So let's see some value counts. So we saw P class. P class was this guy right here. And we can see P class was like, class 3, 1, 3. It kind of knows like how many different classes are there. So we can do that value count. So note that it's kind of similar to, it's kind of similar to unique. It's going to tell us how many of each each class there is, but it's also going to tell you how many are in that class, if that makes sense. So we're going to see, for example, there's actually 3, 1, 2, and then a question mark. Oh, that's good to know, because I assumed at first I was looking at the class, I'm like, oh, that looks like a bunch of integers, right? But if I look at it closer, right, on info, you can see, oh, it's actually an object. So there's actually a string in here. And Pandas is trying to be smart. It's like, hey, I can't make this into an integer, so I'm going to make it into an object, which means a string. And you can see that's why, because some of the values are actually question marks. So that's kind of important to note. So we can see there's, for class level 3, right, or P class 3, 469 values, right? For class 1 or P class 1 is 201, right, and so on. So this is a way to kind of investigate a little bit. Okay. Note, just because I have unique later on here, if I do instead unique, note that's just going to tell me how many different classes there are, right? It doesn't tell me anything about like how many there are. So this could be a little bit extra information. Okay. Survived, I want to see just how many, like, I don't really care too much about who survived or whatever. I just want to see like, what is the definition of survived? And you can basically 0, 1. You either survived or you didn't survive. So makes sense. Okay. History. So this one is kind of fun. So df age, right? So that's going to give me the age of all those values, right? Now this dot hist. Does anyone know what this is going to do?
Highest?
Like what will this do?
A histogram. Huh?
Yeah, plot out a histogram. Yeah. So it actually plot a histogram of the age. So you can see here. And note that you can also feed in extra parameters in here to like bin it differently, but you can see a general idea here. So this is what we call like exploring the data. We don't necessarily have to make it perfect. We're just trying to get an idea of what the data looks like. And you can see here, there's our standard deviation. We have quite a lot of people closer to, this kind of like 20, 30 age, and then drops off pretty significantly, pretty long, like decent long tail into 80. And then there's like stark drop off, right, of like only some who are probably classified as like children. So, okay. So again, we're just getting an idea. Note that we can also do different kind of plots. So if we did a histogram, we can also do a plot, dot plot, and then say what kind. And this is all built into Pandas, by the way. But you can see it's related actually to matplotlib. So kind is actually box. So that's going to give us a box plot. So we can do this guy. You can see if you're more familiar with this box plot, you can actually see a little bit. It's like, oh, here's the median right here. Here's the interquartile range, and then here's the full range itself. And this is from the 25% to the 75%, I believe, from default. But you can see here, these might be considered outliers depending on your definition of what an outlier is. And you can see those points. Okay, quick show of thumbs. We're pretty familiar with this kind of graph. Okay, cool. If you're not, like, definitely speak out. But this is a really common way to kind of this. And note this is the same information, right? It's the same data. It's just being presented in different ways. So that's kind of a useful thing to kind of think about.
One question. Can I have a question?
Yes, go ahead.
So for the histogram example, we can also plot the histogram using the plot, right? So what is the preferential way, like to plot like that dot hist or like a dot plot and then mention it under kind as a histogram or bar?
Yeah, so you're saying like you could just do, I think it's hist, right? Could be histogram. There you go. Like
something.
You can see there's a little difference. Like, honestly, there's not really a preference. Like, if you wanted to do more than this, I would probably say stop using this, stop using this, go get matplotlib going, because you have more. It's more easily like adjustable. But for quick exploration, like, I don't think there's any real preference. I personally like I like doing things that I can do multiple. Like, it's like, oh, I just want to now do a box plot and I just change this. I like that option. But there's not like a real reason why you'd have to do this over the other one. This probably is more common just because you just do this so frequently. Like, you do a histogram that you might just do .hist versus like dot plot, kind equals hist. Like, that's a lot of like extra steps, where .hist is like literally 4 characters. So, yeah. But there's no real preference. Yeah, good question. Anything else? Sound pretty good?
Yeah, I have one quick question. I'm sure I could Google this, but is there any way to access like what those outliers are once you've plotted the box plot? Or
yeah, so in this case, this is kind of hidden away, so there's not much you can do about actually pulling out these points right here. But what you can do is, if you know how this box plot is defining these outliers, like this range, you can then say, okay, like, let me find those parts. And that's when you would start investigating a little bit deeper. Like, I would say this is kind of like very initial exploratory, where you're just like, oh, let me just see what's there. And like, hey, it looks like there's some outliers here. And then you might say, okay, let me go ahead and define what an outlier is, plot that out, investigate what these points are. But from this directly, you wouldn't be able to actually see that and all that stuff. Okay.
yeah, no problem. Thanks.
Right, good question. All right. So, okay, cool. So I'll move on then. Sound pretty good? Yeah. All right. So some missing data. So we saw there was some missing data before. I will reference this little YouTube clip from our, not a little, it's actually like, I think almost an hour long. But one of our other instructors, Jeff, actually does a really great job of like explaining missing data and stuff like that. So I just wanted to point that out. But kind of going into this, kind of skipping over this actual walkthrough, I was like, what is the issue with missing data? Like, what's the big deal? Why should I care about missing data?
You're kind of left with like 3 options, which is to, sometimes you might have to take out like the whole row for that individual. Sometimes you might have to put a 0 or a 1 in, and the weigh the data down. Missing data makes it difficult in terms of how accurate it is to actual sample population, and how you approach that could really skew your results.
Right. Yeah. And in short, like, kind of summarizing a little bit what you said, Sam, is that it's an unknown. Like, we don't know exactly why it's missing. Like, is it missing for a reason? Is it because, like you said, like, fill it in? Like, oh, they just, we could fill it in with the simple value. Like, that's probably what it likely is. Like, and all those situations are going to cause different results depending on what decision we make. So that's why missing data is a big issue about, like, what do you do with it? And you said exactly right. There's a lot of, you said 3 different situations we can really do, which is going to be basically get rid of it, replace it, or actually encode the fact that it is missing. So we're actually going to talk about that. Yeah, great. Thank you. All right. So like I said, we're going to either remove it, we're going to replace it, or we're going to keep it. And we're going to talk about what we mean by keep it. So the first thing to remove it is, like, the biggest issue is that we lose information. Like, if you were dropping, like, let's say, for example, we saw that there was only 200 values that were here. So you're dropping all data points that include, or you're only keeping data points that include the cabin. You're going to only keep 200 out of like almost 900 like data points, which is probably not a good idea. You can still, like, you're still losing some information as you drop data. But sometimes it's like, oh, this is something like it's unknowable or it's so insignificant. Like we have literally millions of data points and we're dropping like 5. Like it would be almost like insignificant to that point where like it doesn't really matter. So I just know that we do lose data, but sometimes it does make sense. So one option, like I mentioned about the cabins, like we can drop the data. Oops, click on this. We can actually drop the specific column. So we can say, oh, drop this column. For example, a cabin out column might not be important enough for us to keep because it's just referencing a column that only like, less than half of the data points actually have. So maybe it's just not really that useful. It's just going to kind of make it more cluttered. So we can actually drop this. So there's a couple ways you can drop the data. Again, like this is kind of closer, like if the majority are missing, it can affect our prediction, stuff like this. But we can do this by drop columns, like df.drop. So df is the data frame .drop columns, and we say what columns we want to drop. We could also do df.drop bc, but make sure you do axis equals 1. And that basically just say, instead of doing it by row, it's going to drop it by columns. So there's 2 different ways you could do this. Okay. Now, if you want instead to drop a specific row, is that you probably want to drop, like a row. For example, like I saw there was the one that's like, there's 2 people missing with their, I can't remember what it was. Like, I don't think it was age, but it was like 2 people, like their attributes are missing. And maybe that was a very important attribute. I might just drop those specific rows, especially if I have enough data. But as long as you're not dropping too many values, it's usually pretty good. Though I always say is that if you do either of these cases, dropping columns or dropping columns, like have a good reason why you want to drop column. If you're dropping specific rows, I would say like have a good reason why you want to drop those rows in particular. Like have some like essentially some evidence, some backup of like why it's okay to do this. Okay, and explore it a little bit. Maybe you find out that that data point, like, oh, it's missing, but I can clearly see like this is a duplicate of another data point. So maybe you do include it and just kind of fill in the value. So you can see here, I'm making just a quick on data frame, ABC, and then this way I'm just dropping. If I do df drop 1, 2, you'll see that it should drop, I believe, these 2 rows. And there you go. You can see it actually drops these 2 rows. Okay. So this way you can like have like, you can specify a list of like specific numbers, or you can even do things like, drop NA. So df.drop NA. This actually will say drop all like, the missing values, which sometimes will be fine if you don't have that many missing values. Okay. Sound pretty good? Cool. All right. So that's our first option. This is kind of like, I like to say like the machete way of doing it. I'm just chop things off and just like, like, oh, don't worry about it anymore. But this can affect our prediction, especially for dropping values like that are significant. And so one thing might be is like, maybe they're just like, like most of the data is pretty good, but like there's just that one missing value. And it's like, well, it's probably likely this way. So one way we can do this is just filling in with, for example, missing values and just filling out with a specific value. So in this case, I'm actually taking fair. So I think fair was the one that had some missing values in there. And I'm just going to fill out NA and just take fair, the median of fair. And so usually we'll replace it like the median or the mean or some other default value. And I can say, okay, go just replace it with the median. And that'll actually replace the missing values with the median value in here. Okay. There's some other more advanced techniques, for example, we'll later on talk about something called KNN, K nearest neighbors. And you can say, okay, whatever is like most like your value, fill it in with that value. So maybe like, for example, let's just say the fair is missing for this value, but like there are people who are like 80 years old, of this P class, and we have values that are similar to that. We might want to fill it in with, not with the average of everyone else, but maybe values that are closer to that. That'd be kind of the idea of KNN. And we'll see that in the future too. Okay. So makes sense? At least this guy right here. And note that we can
Victor,
put whatever value you want. Oh, yeah.
Hey, Victor, one quick question. Do you have any rule of thumb on like when you would fill in the median, let's say a column, if it was 5% incomplete or 2% incomplete, it seems kind of reasonable maybe to backfill it. But at some point, do you have like a threshold where you wouldn't go down that path as a rule of thumb?
Like,
sorry, like say 10% of the data.
Like when you start filling in or not, right?
Yeah.
Yeah, so that's a good question. So My general rule of thumb is that I try not to throw out data first, and I say, why is this data missing? And so one thing I might look at is saying, I don't like doing a rule of thumb because when you give a rule of thumb, it becomes very easy just to do that thing and then not investigate further. A general rule, like I've heard, is like if you're missing 20% of that data, like it might as well just drop it. Like it's going to be significant. But there's a whole bunch of caveats to that. If you have 20% of the data missing from one data point, so if you have like 10 columns and 2 of the columns are missing, I might not want to drop that full data point because that's still significant. Like maybe there's still stuff I can do with that point. If a column's missing 20%, I might still keep that column and just kind of like reformat it and stuff like this. Like we'll talk about the next part, which is keeping it and actually just say, hey, this data point is missing data, and I'll kind of state on that, if that makes sense. I'll kind of like, what's it called? We'll see this in a second, but basically I'll say, oh, this data point is missing data, and here's a default value for right now. The other thing I like to say is that like it depends on distribution. So like if you see the missing data, like I'm just going to scroll up here a little bit, and let's say I find age is like a really important aspect I want, and I find the missing data is like, oh, we have missing data for this one, missing data for this one, like this age group, this age group, this age group, and it's like uniformly like missing data across different age groups. I'd be more comfortable just dropping it because it's like, oh, well, I have other representatives across the different age groups, which I found was an important factor. But if I found, for example, there's the same, let's say I have like let's say 100 different missing, like 100 data points that have missing values and something that's not age, and it's spread across the different age groups, I might be like, okay, cool, I can just drop those or even replace them, and I'd be okay with that. But if I instead saw 100 data points and they were all aged like 30, I'd be like, that's really weird. Why is all the missing data from like this specific group? And that's when I would investigate a lot further. So that's where like I'm kind of like hesitant to say, oh, you should do it in this case. You might hear people quote certain values and stuff like this, but in the same way, like outliers, like people love to say, oh, 2.5 standard deviations from the mean is an outlier. And it's like, why? Why is that an outlier? And like, I don't like doing that because people say, oh, it's by this definition. And you're like, but that definition is just kind of like a rule of thumb, essentially. It's not actually like a specific mathematical reason why you need to drop these values because they're outliers or why these are outliers. It all depends on the situation. So in short, it's that like missing data kind of shows the colors of data scientists of like how they approach things. But in general, is that if you have a lot of other, I would say if you have a lot of other examples of missing data, then you probably are fine dropping it if you have a significant amount of data. But if you don't, you could probably just fill it in with a value that's similar to those missing values or those data points that are similar that aren't missing values, if that makes sense. So yeah, I don't
Thank you.
Yeah, no problem. That was a long-winded answer that basically says like it depends. So Sam, Sam L, I saw you raise your hand.
So when you actually replace like a missing data with like a median point, like you said, okay, I guess the question is how big should the missing data size be for you to not like?
Right. So you're saying like, oh, I'm filling in with median, but like, what if the missing data, like I'm extreme and 95% of the data is missing values.
Right.
And then like, I'm trying to fill in. Yeah. So I would say, again, it kind of like depends on the situation, but I would say as you get closer to like over, like, how to say this? If you have a significant amount of data, like it doesn't really matter too much if you're dropping data as long as it's uniformly spread out. Right, it's versus like everyone's just 30 years old. So let's pretend like it's not uniformly, or it is uniformly spread out. So it's not just like a whole bunch of 30-year-olds who are missing data. I'd say as you get closer to like the 10, 20%, that's when you might want to start looking at saying, like if I start filling in this missing values, is a significant portion enough where if either by chance or just by, why they're missing, is that those missing values actually would have affected the median significantly, then I shouldn't be filling it in with the median, right? Because then otherwise, then I'm just basically solidifying that median as like, that's the actual value. So I would say that happens usually between the 10 and 20% mark. for most situations. And again, this is where like missing values can be usually done like with a machete, like just slicing things across, or done with a scalpel of like really meticulously making sure like what parts are missing. And with very large data, so this is where I kind of go a little bit past like this specific situation. But when you're actually looking at production, we're actually saying, hey, I'm going to make a pipeline of data coming in, making predictions, and pushing that out, is that you won't have the luxury of taking your time and figuring out exactly what's going on for each missing data point. So you kind of have to use the data that you already have as kind of like the starting off point, because most is going to be done automatically. So usually in the long run, it does pay to take some time for the missing data and say like, why is it missing? Is there some pattern in there? Or is it just kind of like just happens to be missing data for whatever reason, or even ill-formed data? And then solidifying those practices then with like when you feel confident enough, and then say, okay, now if we get new data coming in this pipeline, you can feel relatively confident, like, oh, it's probably going to be fine. But also in reality, it's what you'll do. And this is going beyond what we're talking about, but like in production, what you probably would do is that as new data comes in, you would systematically take in that new data and see if it differs greatly from the data you originally started off with. So, if you're replacing, missing values because the median was like, let's say 50 for whatever reason, and then you find out your median value for the new data is coming in like 90, right? Your strategy for replacing the missing data might not be valid anymore. In fact, maybe your whole prediction model is actually no longer valid. So you might actually have some automatic checks where say, hey, if the median value is very different from this value, stop the pipeline, let's reevaluate and see if we can do a better result. And there's a whole bunch of ways we can automate that stuff too. But that's kind of like more, to be honest, that's more higher level than what we're even talking about right now. And honestly, that's not even something you necessarily need to know right now, like going into a data science job. But it's something like kind of keep in mind is that like what decisions you make with your data can still be like a special form of all the data that will ever be produced in this situation. So hopefully that makes sense. Like when I say that, because like data coming in, data will change over time and we get like this degradation. But anyway, 10 to 20%, right? About like when you start thinking of medium. Cool. Yeah. As you guys might have noticed already, I like talking a lot, especially these little nuances and stuff. All right. All great questions, by the way. So cool if I move on then to keeping data. Is that pretty good? Okay, cool. All right. So yeah, really short thing. Basically, like when you keep your data, what you might do instead is actually make a new category. I think even Samar mentioned this. Make a new category that says this data is missing. So like, is missing true or false? Like that might be like something, and that might happen a lot where you find that the missing data is actually important enough, like it signals something. So kind of spoiler it with the what's it called, the Titanic data. Some of the missing data that's in here is relevant to basically what kind of like what were they like, what was their job in the Titanic? Were they a passenger? Were they a captain? Or were they below decks, for example? And a lot of the missing data comes from the people who basically were more like lower class. So that in that case, you might want to be careful about dropping things because like, oh, that actually signals something about who this person is. So kind of be aware of that kind of situation. Okay, cool. All right. You can also like same thing, like make its own category or bin it for numerical ranges. So like if you're like not really sure and have a separate bin essentially for missing value or something like that. Okay, cool. All right, so just some quick example code. I just want to show you. df is an A. You can actually see like you can see there's true, false, and stuff like that. You can see what things are missing. No, basically this is very similar to what's it called? When we do a mask, right? So I can actually pass this into a df. I believe this will work. And you can see that basically none of these are missing values because we actually got rid of some of the values that were actually missing in here. So just kind of be aware of that. All right. Anyway, so you can see this true, false here. And you can see this df dot isn't sum. This is basically, we'll just take all of this stuff because remember, true and false are really just zeros and ones. Like Python can treat it like this. So we can actually sum up saying, hey, add up all the zeros and ones, and you can actually see all the missing values in here. So you can actually see like, oh, for example, there's 177 missing ages. Cabin is 687, like we talked about. And there was 2 missing on the embarked. So this can be convenient where you just want to explicitly know what is missing values. Okay. Sound good? All right, Cool. So let's see here. We got, oh, good. We still got 30 minutes. Sweet. So we're right in schedule. All right. And you guys have been asking really great questions. So that has been great. All right. So let's go over some data cleaning. So this is going to be more of a high level, like what data cleaning looks like. And this is going to be very close to like if you have data, like for example, your first project, you're getting in data, you want to make sure the data has been processed enough to understand like is your data actually representative of what you're looking for? So we'll kind of talk about this. So overview, right? Some objectives that we're going to do. So things that we're planning to do that by the time like we go through this part is we can split the data frame into subgroups. So we can use things like group by, aggregation functions, minimum, maximum, count, and sum. Okay. So basically the idea is we can split the data frame into different parts, kind of pre-processing it into what we need. We can explain the different types of joins. So this is especially useful if we have different data frames from different sources. We can combine those sources together. So we can do something called inner, outer, left, and right. For people who are familiar with SQL already, that's essentially what this is right here. They're SQL joins. And then explain strategies for missing data. So we kind of talked a little bit about that, but categorical versus numerical. Usually that's kind of like the data kind of gets split into, like, is it categorical data or numerical data? And those are gonna, depending on what situation we have, we might deal with that data differently. Okay, cool. So some functions for data cleaning. So first thing, we talked about Lambda functions. So what's really nice about Lambda functions, they're like one line, you can put it right in there. You can experiment and solve for individual cases first. So you don't have to like dedicate a huge function just to like, you know, put this in somewhere. You can write the Lambda function right then and then modify and stuff like this. And then you can generalize your solution. So you can kind of like make a function apply to multiple situations. And then you can watch for edge cases and exceptions. So again, this is what's kind of nice about, you know, data science. When you're experimenting, you can write kind of like things like right then and there and experiment it. And then, you know, if you feel necessary, you can solidify it with like a more formal function that's documented and stuff like what you're doing. Okay. So aggregation functions, I kind of mentioned this at the kind of objectives, is we have things like min, maximum, mean, median, count. So they're pretty self-explanatory. Note that basically it's going by each column in the group. So if you do apply this onto a data frame, I believe it should actually put out min, for example, for each column. So, or we can do a specific column. So kind of look at what this looks like. So I put a little note here. Being familiar and comfortable with data frame splitting using aggregation will be very important for correctly using pivot tables, stack and unstack, and multi-hierarchical indexing. So this is kind of mentioned a little bit in the curriculum, but pivot tables, kind of quick thumbs up. Who's familiar with pivot tables? Okay, if you're not, don't worry about it. I see some sideways and stuff like this. Excel people love pivot tables, and so you'll see, depending on your background, you might see a lot of people like really like talk about pivot tables a lot. But basically, just know it's a way to aggregate the data. Stacking and stacking basically is to get rid of when you get aggregation, stuff like this, and it's kind of similar with multi-hierarchical indexing. So just kind of be aware that like this will change. Like make sure if you're doing aggregation and then doing a min max, like you should probably make sure you understand these concepts before just applying them straight up. Okay, so just gonna show you an example. So let's do our diabetes data set. So remember this guy, we just saw it earlier today. Okay, and let's say, for example, we're just gonna get sex and we're just gonna get the max, right? So you can see here, I can get sex right here, and you'll notice right here is like, whoa, what's going on? So the first thing you should know is that I'm grouping it by sex. So that means that each group is going to be by, in this case, I did group by sex because there's only 2 classes, right? So you can see here, here's one class, you know, we can say that there's female and this is like male, for example. And you can see here is that this is getting the maximum value for each of those groups. Does that make sense? So the age maximum for this data frame for this classification is going to be like 0.96 versus 0.11. So you can see there's a difference already in age. So this is kind of a quick way for you to like see these parts. I just realized I'm going to put one extra thing in here. I don't think this will mess me up, but let's just do df. I'm going to do the bad thing and overwrite my stuff, right? So if I want to write this as, what's it called? I want to apply this everywhere, right? I can do df sex, and I'm going to just rewrite this into male female just to make it nice and easier. So I'm going to put m if, oops. Gotta pass in a function lambda x, right? So I'm just saying the value in here. So it's going to be m if x is, let's say, less than 0, doesn't really matter, else female, okay? And that way I can have a little bit easier for us to, sorry, I'm just kind of making it so we can see this a little better. I think people are a little more comfortable with this because other than using values. So now if I do group by sex, you can see female, male. Okay, same thing. I just wanted to make it a little easier for us to see. So you can see a little bit is that, for example, like this doesn't seem to be very different from each other. It seems like the maximum values are still there. But you can see here, for example, like the BMI is a little bit different, and then age seems to be significantly different from each other. Okay, at least, you know, I don't know the scale of this is, but they look at least different from each other. And I can do things like, you know, for example, the mean. And you can see there's the mean right here. Okay, makes sense. Cool. All right. So we can also do things like we can group it by multiple attributes. So in this case, I'm actually going to group by sex and BMI. So we'll see what this looks like. And then in this case, I'm like, I don't really care about, you know, let's just say I don't really care about the other features. I just care about the blood pressure, BP, and S1. I can say, okay, let me just get just those aggregations, right? So note that basically I'm doing, I'm making a new data frame right here. I'm doing df dot group by here, making new data frame, getting just those columns, and then doing that the dot mean. And you can see if I do this now, it's kind of nice is that I actually have, you know, the sex right here in the BMI. So the BMI is actually separated for each group right here. So you can see I have a group basically of all female. This is this first part. And then the second part is all male right here. And then it's subcategorized again by BMI. Or sorry, yeah, BMI. Make sense? Okay, and you can see I only getting blood pressure, only S1. So this is a really convenient way to kind of just like quickly look at this. This is kind of similar to like what you might start doing with a pivot table. All right, sound pretty good? Thumbs up?
What is
thumbs
the
down?
R list
Mhm.
again? Where'd you get that from? How
I
does
just
R
checked.
list?
I just
Oh,
chose
you
it.
find it. Oh, I'm
Yeah.
blind. I'm sorry.
That's right. I made that, ironically, I made that to make it a little bit easier to read, but I could have just replaced it with, you know, like this. So, yeah. So this is a nice way. So if I didn't, for the record, if I didn't do this, let's see what happens if I don't do this. I don't think anything will break. Oh, that breaks. There we go. You can say just every attribute. So I was just thinking like, I don't want to see everything. I just want to see some things. Okay. Cool. All right. So yeah, again, a really useful way, kind of similar to like if people are familiar with pivot tables.
It would be
Yeah,
it would be nice after you, so whatever attribute you calculate, to say that the attribute on the column name. For example, you're calculating the mean. So under the age or whatever column, it also says it's the mean of, you know.
So like age mean, BP
Yeah,
mean,
something
something
like
like that. Yeah, you could do something like that. I think for the most part,
Do
people
we have
usually
to
use.
like rename it? Column,
Yeah, so you could, for example, let's just check this out real quick. This is just a data frame. So data frame 2 dot columns. Let's see what those columns are. You can see like this. I could, for example, dot rename the specific column and like rename, like, oh, I want to rename age to age mean if I really wanted to, or something like that. Usually that's not done too frequently for because this guy right here, if you think about it, is always the averages, right? So usually it's like, oh, we kind of know by context, like DF2 is probably the worst name I could possibly have named it other than DF. DF mean might make more sense. Like, and then it's like, okay, these are all the data. This is a data frame of means, for example. And then I would be able to understand like, oh, just context. But yeah, you could rename it if you wanted to. Cool. All right, yeah, I'll keep going then. All right, dealing with missing data. So we kind of talked about a little bit about missing data, like what can we do? So first is to detect missing data, right? So we can do is na.sum. So we saw that at the end of that last notebook. We can do some, and then we can actually use some placeholder values. So we can actually look at things like 0, 99, dot value counts, right? We can actually see how many values are actually missing and stuff like that. And then categorical, we would look at unique, right? Oh, sorry. I was thinking of something. Numerical meaning like numbers 0, 99. I don't know why I put that in there. I don't know, past vector is weird. But dot value counts would be telling us how many happens in there. Dot unique would be categorical. Note that if you do a dot unique on a numerical, it's just going to list every single value essentially because there might be some repeated stuff. But if you have a float value, like it's just going to show you all those unique values, which isn't super useful. So just kind of know there, like be careful with that. How to deal with this missing data. We talked about it. We can remove it. We'll like drop out an A, for example, or do something a little more fine-tooth. We can replace what we call impute. So we can kind of calculate what we should replace it with and actually replace it with that. That's where you get like fill in A. I talked about like using, like, we didn't show this example, but there's something called like k nearest neighbors, KNN, and you can actually use a KNN imputer to impute and figure out basically what values are close together and actually put those in there. So that's really useful. So you can do things like doing things like the median value. You can also do things like, replacing it, for common value. You can do it the one that's the most common value on there and actually put that in there. And then, so real quick, I kind of skipped over this. Why might we use the median instead of mean? Does anyone know?
So we don't skew the data, right?
If we have big outliers.
Yeah, so I think Sam and Becky, you guys said kind of like related things. It's that basically the idea is that if we have skewed data, right, the mean and median are going to be more separated. And then Becky, like that's kind of related to outliers, right? If you have a lot more outliers, the mean is going to be dragged towards those outliers. The median just tends to be more robust, meaning that it doesn't tend to be changed too much by those outliers. So typically, you'll see me use median, and you'll see a lot of people use median. I'm one of those people who's just like, I don't know why you'd ever really use mean. I feel like median just usually for most situations makes the most sense. But anyway, that's kind of a little thing I wanted to point out there. And then things to keep, we could also keep it, right? So we can make it a categorical and just label it as missing NaN. So this could be a separate category, or this can actually replace the category sometimes, and it can give us extra information. And then numerical. We can do some numerical binning of the values, right? So we can say, for example, age, like, oh, this is the age from like 0 to 10, 10 to 20 or something like that. And then like there's also a bin saying, these are all the missing values. So those bins are really like more like categories at that point, and we can treat them like that. Okay. Cool. All right. Yeah, so I won't repeat any more of that. I think people understand pretty much about missing values now. Okay. And then combining data frames, I just want to mention is that we can combine the data frames by outer, inner, left, and right. So you'll see this again in SQL, so we'll talk more about that then. But just know that outer join basically returns all the records from both data frames. So if we have like a data frame do an outer join, we're basically going to say all the records between those two. An inner join is just only going to include the ones that have matching keys. So if you have data frame A, data frame B, and you do an inner join, it will only keep records that exist in both data frames. So usually that's going to be like some by ID, like say passenger ID. It's like, oh, we have passenger ID over here, passenger ID over here. They're both passenger ID 100, so they match up and they combine them. If we have passenger ID 101 and 101 does not exist over here, it'll just drop out. So it won't be kept in there. So kind of be aware of that. If you do want to keep, let's say you have a table and you want, it's like, oh, everyone that's on this like manifest, this data frame, we want to keep everything here and then just kind of hook up whatever's over here on the side. So for example, let's say like the left side is like the passengers on the Titanic, right? And then on the right is like all passengers for the, whatever year the Titanic sank. You'd have like all the different ships and all the different passenger IDs. Like you don't want all of this stuff. You just want the stuff on here, but then combine it over. You would use something like a left join, which returns all the records from the left table, as well as any records on the right table that have a matching key. So it would add extra parts. But if it was something missing on this right table, then it'll just drop it. Or not, it won't drop it. It will keep it on here and it'll just have missing values. Okay. I put right join in here. In my head, I never think of right joins. Right joins is the weird like cousin of like left join. Basically, it's the opposite, where you keep everything on the right table, but on the left table. I never use right join. I always write everything in left joins. So anyway, cool. Sound pretty good. I didn't show you like how to do this, but just kind of know this terminology. I would say just know these like two. Outer join basically means combine everything. Inner join only if they both exist, and then left join is like if they exist in one table, but maybe not in the other. Cool. All right. So yeah. Any questions about this stuff? I kind of went through some stuff pretty quickly, but most of it's kind of, you can see, not necessarily code.
A quick question about section 2. What you're doing right there with the data frame group by stuff, you're getting are you getting the average of everything that has that exact BMI per sex as well?
That's right. Yeah, this BMI, you're talking about how I'm doing. So maybe I could help like this, right? You can just do that. So you can see I just wrote it right here, so it's a little bit easier for us to read through. Is that you can see is that this BMI, so sex is obviously just two categories, F and M. But BMI here is saying, okay, get all the F, right? All females here. And then it's actually getting for every single BMI. So yeah, it's going to be, if this is like this is not the best example, but I was trying to figure out one that would be closer, you know, in category. This is really doesn't have this,
right.
Yeah, this one doesn't really have two categories. But if I had another categorical variable, that would be probably a better thing here. Yeah. But good catch. Yeah, that's literally saying it's every unique value. So like you can imagine like if there's like literally a float for like every female has a different BMI, like the BMI is not just like 21, 22. And there's something like 21.3, 21.31, like this would be just basically, this would kind of be pointless. Cool, good question. Anything else? All right, so, all right, cool. We got last one, just enough time to talk about aggregation. So I kind of mentioned a little bit aggregation, so let's try to play some stuff. For the record, this one always broke my brain when I was first learning about it. So if you don't see this immediately and you're like, what's going on? Like, don't worry. Like, I think it does take some time to get used to. If people are used to like, pivot tables and stuff like that, I think you might be a little more used to this. So we're gonna get our diabetes data set again. We can see there's our age, our sex, all that good stuff. Okay. And then we can go ahead and do aggregation. So we can group and aggregate our columns of data to do other operations. So we can do things like, you know, how described with some summary statistics. So you can see here, I'm just gonna split this up where I have just BMI is my, just the BMI series right here, okay? And then let's just go say, okay, let me just do BMI.count, BMI.min. You can see a little bit what that does. It's just like, okay, let me just get the count of that BMI, count of that min, or the minimum of the BMI. You can see that values right here. Same thing with max, okay? Pretty straightforward, right? When we do actually group by, right? So we group by sex, right? We can actually get like grouping it by sex and actually getting those values. So we saw this already, okay? And then we can do some things like, okay, let me just get just the BMI column, right? And you can say, okay, group by sex, but then only get the BMI column and then do the minimum. And you can see here, we actually have a nice little weird little series right here, but this is basically because this is the sex is, because it's a float value, it really should be categorical. We can see here, that's basically for the first category, this is the BMI minimum, and this is the BMI minimum for the other category. Okay, cool. You can see here with this work too. So note this a little bit, wait, it's the same thing. Well, what is past Victor talking about? Ignore that. I don't know what past Victor is doing. Oh, well. Okay, I don't know what I was trying to point out here. It must have been something in the past I've changed it.
Maybe you wanted to write max.
Yeah, maybe. I feel like the way I question this makes it sound like I'm missing, will this work? And I don't know what I did. Okay. Yeah, that would obviously work, but okay. So an alternative way we can do this is, so we do the group by sex, right? So we have sex and then apply numpy min, right? And we actually gonna apply, it's kind of like map, but it's for like across. We're basically going to apply the minimum across each like series and get the minimum across each series and then get BMI. So that would look like this. Oops, I didn't import numpy. What is past Victor? This is why I get to blame him and say, it's your fault. There we go. I don't know what else to do. There. So now we can see you get the same values as we did earlier right here. I'm going to get rid of this guy. You can see the same values. And note that if I did this, right, you can see as that basically this is just applying the value minimum, and that's applying that minimum across each column. So essentially it's getting the minimum for the age, minimum for sex, but for each category. Does that make sense to people? Okay, and then of course I just asked, oh, just give me the BMI, oops, the BMI, and you can see, there we go. Okay, cool. All right. Cool. So multiple aggregation. This is where we get kind of broken brain stuff. Is, at least for me, we can use aggregation by multiple columns. So like we showed a little bit, like we can do group by like sex in age. So now we have the sex, and then we also have the age category, right? Last time we did BMI, and you can see get the maximum value. So you can see a little bit of what we have here. But this is kind of a funky thing because you'll notice that like they're at different levels. Like that's not actually just like a display thing. That's actually saying like, oh, there's actually a hierarchy of a stacked column and stuff like this. So you can get some weird stuff where if you want just like this value, for example, it's kind of hard to grab it. So we'll kind of show you what this looks like. So this is what we can use like unstacking. So I grabbed this from, I can't remember where I grabbed this. Oh, it's from the curriculum. I grabbed this icon right here. So if you look at this, like, see if I can get them both kind of, there we go. So you can see like this is what our form is taking right now. We have the first column, right? The second column that we're grouping it by, and then the actual values in this case, you know, like AB, 1, 2, it's like BMI and BP, right? So thing is, it's multi-index, right? So like you see like, oh, this is not really like most ideal. Sometimes we want to actually grab, like we might actually say, okay, we actually want these values as a separate part so we can actually grab them out separately. So you can see like bar and baz. In this case, say, hey, we want these categories bar and baz to actually grab them out. So this becomes now our new kind of like data frame. And so we have something called unstack. So you can see what happens here is this first index actually gets stacked out. And then this is the category. This really should have category names. It's like, okay, the first value is going to be this, but it's by bar and baz. So this is kind of like a pivot table, if anyone's familiar with like how, not exactly a pivot table, but it's related to how like you would deal with pivots and like unstacking and stuff like this. So just to kind of show you guys a little bit what this looks like, I'll have our maximum value. So you can see that's our, sorry, that's our table right here. And say, okay, if I unstack sex, look where sex ends up hopping over to. And you can see here is that now our sex value right here is up here and our age is right here. So now we can actually grab, it's referenced it for, how do I say this? Like each BMI now has a sex value, like for this sex and the sex. Hopefully that makes sense to people. So I'm just gonna add one extra thing just to make it a little bit easier for us to deal with. Let's do df sex. I should have done this before. Pass Victor. I like blaming Pass Victor too because he can't defend himself. Okay, lambda, I'll just call it M. If, oops. If X is greater than 0, else it's F. It's a little bit easier for us to see. There you go. So there you go. Now you can see a little bit. It's like now we have it organized. We say, okay, here's the females, here's the males, and you can see a little bit of this stacking right here. And note now that we can actually kind of like, sometimes people prefer referencing it in this way because now you can a little bit see like, okay, for age, and age is maybe not the best category in this case because it is a numerical value. It could be better if it was categorical. But for example, let's say age is like teenager, right? Or like, 20-year-old or 30-year-old or something like that, like in their 30s, is that you could see then the BMI. You can actually see like, oh, like no one in that category of age for female has a BMI, or like, there's no one in there that has that we can show a BMI. Versus if I do this guy right here, you can see a little bit is that this category and this category doesn't quite match up with each other. I'd have to kind of search through here and find the relevant categories to compare the two. Does that make sense to people? Of the difference in like what might be the reason you want this versus something like this? Okay, thumbs up, that makes sense. So I always be like, ooh, I don't know.
But it's just saying there's no males at that age, right? That's all it's saying.
Yeah, that's what this is saying. Yeah. So, but then you can also compare like the male, like the female, like people. Let's just pretend this is like 30 people in their 30s. So people in their 30s, for female, their BMI was this versus. Oh, sorry, someone in their 30s, their BMI who is female is this, and then for male, the maximum BMI is this. So you can compare directly those extra categories with like your subcategories. So this might make sense in some situations. I would say this probably makes more sense where you unstack the one that has like, 1, 2, maybe 3 categories, and then you can compare those 3 categories together, and then you can see this other category right here. Cool.
I'm not sure if this is too advanced, but how would you bin the ages so that it kind of looks like you can kind of group a couple together?
Yeah, you can actually create bins in Pandas. So we're actually low on time, but I'll kind of point you in right here. So if you never know exactly, you're like, how can I bin values? You can just do, I like to just do Pandas bin values. oops, I spelled it wrong, but Google's smart enough. So you can see here, there's actually a function called cut. And so this obviously I kind of know where to go towards, but you can see here it's like bin values into discrete intervals. And you can even see, I love the documentation because usually I give an example. And here you go. You can see here, I have this NumPy array, right? And you say, oh, cut it into 3 different categories. And you can see a little bit is that you can now have these 3 different categories right here. So it's like, oh, are you going from this value to this value or this value to this value? Okay. And so you can actually create bins in that way. Yeah, good question. Because it is definitely, like you can see here, this is probably more common, like labels, for example. Labels is bad, medium, good. You can see here now, each value now is going to be mapped to saying it's bad, saying it's good, you know, medium, medium. Yeah, makes sense to you?
Yes.
Cool. So good question. And general answer is like, you know, a Google search or whatever search you end up using, like usually provides you the right answer. Because like if you didn't know like cut, like it's like I don't remember exactly what the value is, but I think this is possible. You can say did pandas bin values, and you see like pretty quickly up on the first few ones is what I'd want. And of course, Stack Overflow is a little bit more like you can see these questions spelled out a little bit. So where someone's asking maybe a little bit of like saying, oh, how do I do this with the value counts? You can see a little bit of someone walking through like what this looks like. Yeah, question. Yeah, and that would probably be ideal for this case because these are probably values all spread out over. Okay. Yeah, we got like another minute. I do have to head out in a second. Any other questions? No, pretty good. All right. Well, I'll stop recording here. So let me go ahead and stop sharing and stop recording.